When we're doing trig identities, there are infinite ways to do trig identities. So the ones I'm going to show you, they're just going to be one way to do these trig identities. So there's some strategies we can use, and so it's good to make note of the strategies. If we do enough of these trig identities, you'll notice that there really aren't too many variations on these strategies. Okay, so here I'm starting with this identity. I have tan theta on the right. I have sine theta, tan theta on the left over cos plus 1. So one of the strategies we can use is we can rewrite this all in terms of sine and cos, because every ratio can be written with sine and cos. So I'm going to just do that. I'm going to get sine theta plus sine theta over cos theta. And that's all going to be just cos theta plus 1. Okay, on the right hand side, and we can work on one side, we can work on the other side, or we can work on both sides. So I'm going to change that tan into sine over cos. Okay, so another strategy I can use is I can get common denominators. Now, if I get a common denominator on the right hand side and the left hand side, that will, if the denominators match, then the numerators have to eventually match. Okay, so I can multiply both one side by cos theta plus 1 and the other side by cos theta, and that will solve this identity. Okay, so this is kind of a quick way of doing it. I'm going to multiply 1 plus cos. Okay, so I'm going to do 1 plus cos. And I switched it around for a reason, because it'll just make it a little bit easier to identify the common parts. Okay, so I haven't changed the right-hand fraction at all. And I'm going to do the same to the left-hand side, but this side I'm going to multiply by cos theta. So by multiplying the top and bottom by the same, I haven't changed the left side at all. I haven't changed the right side at all. I could do this independently. I can do this in two separate steps. But what I've done is I've generated a common denominator for this identity. So on the right-hand side, sorry, I'll start with the left-hand side. On the left-hand side, I'm going to end up with cos theta sine theta plus the sine theta is going to cancel out. Sorry, the cos theta is going to cancel out. I'm going to be left with sine theta. That's my numerator. In the denominator, I'm going to end up with cosine theta plus 1. And there's the left-hand side. The right-hand side, this is going to end up being sine theta plus sine theta cos theta. The numerators match, and the denominators must match because we did this as a common denominator. Okay, so that now has resolved that or proven that identity. Now, the strategy I used here, again, I converted things to sine and cos to make it a little bit easier. Unless I can identify any identities right away, I'm going to convert to sine and cos. The second thing I did here was to match the left side and right side identities. I tried to match the denominators. If I can make the denominators match, then the numerators must eventually match. Okay, the one thing that we don't want to do is we don't want to come up with some new identity. Okay, so make something up that doesn't work. As soon as you do that, you started with an identity that could be proved to one that can't be proved. So once we make a mistake with an identity in here, we won't be able to prove this identity. So you have to be very careful. Don't make up a new identity that doesn't exist. Okay, so here I'm gonna I've got a 2 theta, so I'm going to use my double angle to convert that to a single angle theta because I have to have my thetas match. And I'm going to do the same thing as I did before. I'm going to convert that cotan theta identity, and I'm going to change that to cos theta over sine theta. And on the right-hand side, on the left-hand side here, what I'm going to do is I'm going to convert that to 1 plus. And before I do that, I'm just going to convert the denominator into its single angle identity. So if I look at my identity sheet, 2 theta, there's only one identity for that. That's 2 sine theta cos theta. Okay, so if I want this to look the same, I've got an extra plus here. So what I want to do is I want to use the double angle identity that will eliminate that plus. So the double angle identity that I'm going to use for this cos 2 theta, okay, I'm going to use 2 cos squared theta minus 1. And using that identity, what ends up happening is that minus 1 and plus 1 cancel out, and that gets rid of that extra plus 1, which I don't really need because there's no extra plus 1 on the right-hand side. So now my identity looks like this: 2 cosine squared theta over 2 sine theta cosine theta. We can see that a bunch of things will cancel out here. The 2's cancel out. One of these cancels with one of those. And now I've solved my identity, or I've proven my identity. In the numerator, I have 1 cosine theta. In the denominator, I just have 1 sine theta. So I can see that the left side equals right side. I've now proven this identity.